Hello, today I'm going to talk about how mining works and the distinction between POW mining and POS mining, and the Byzantine general's problem and the relationship to the POW. The POW is proof of work. In proof of work system like Bitcoin, mining involves using computer powers to solve complex mathematical problems that validate transactions and create new blocks on the blockchain. Um, so the first step, it's a transaction verification. So which means that the miner collects a set of unverified transactions from the network's mempool to the new block. To validate a block, miner must be find a number called a nonce. That when combined with the transaction data in the in the block and passed through a hash function, produces a hash that meets a certain criteria. Usually, the hash must be started with a certain number of zeros. So for the POW, it's finding a nonce requires many attempts and is computationally expensive. This effort is a work of POW. The process is designed to be difficult to ensure that it takes considerable effort to validate transaction and secure the network. Block addition: once the correct nonce is found, the block is considered validated. The miner broadcasts the valid block to the network. The other nodes, for example, participants in the network, verify the work. If it's accepted, the new block is added to the blockchain. And last one, mining reward. As a reward for the effort, miner receives a combination of newly minted cryptocurrency and transaction fees. For the POS, proof of stake mining, so first, the proof of stake represents a different approach to achieving consensus and doesn't involve the heavy computational work of POW. In proof of stake, the process is often referred to as forking or mining rather than mining. Here's how it works. First, the stake, instead of miners, there are validators. Validators are chosen to create new blocks based on the amount of cryptocurrency that they hold and willing to stake as a collateral. Validation selected validators check the transaction for validity and create new blocks. The likelihood of being chosen can depend on the size of stake, the length of time the coin have been staked, and other factors depending on the specific implementation. Forking rewards: instead of earning a mining reward through a computational work, validators earn transaction fees as a reward for validating new blocks. So the last one, security. If a validator acts maliciously or fails to validate correctly, part of their stake can be forfeited. This stake forfeiture is designed to keep validators honest. Byzantine general problems. The Byzantine general problems is a classic problem in computer science and distributed computing, which illustrated the difficulties that decentralized networks face when attempting to reach consensus in the process of potentially uh, trivial notes or general in the metaphor. The problem persists that several divisions of Byzantine army, each commanded by different generals, encamped around an enemy city. To successfully conquer the city, the general must agree on a common battle plan. However, they can only communicate via messengers, and there is a possibility that one or more generals might be traitors who will try to confuse the others. The challenge is to find algorithm that allows the loyal general to reach agreement. For the relationship between POW and the Byzantine general problems, um, I basically gave 3 parts. So the Byzantine general problem is um, um, all agree representing the difficulties decentralized system having achieved consensus in process of fault or malice. It asks how to guarantee that all loyal generals will take the same action when some generals may be traitors who could be sending false signal. The first immutable record, the in blockchain, the ledger acts as a historical record of all transactions. For POW, ensures that once a block of transaction is added to the ledger, it's extremely difficult to alter. This immutability is critical. It's making sure that even if some nodes are dishonest, they cannot easily change the already agreed upon history. Um, Politic verification. In the Byzantine general problems, the general must be communicated in a way that their message cannot be tampered with. In blockchain, the verification on the POW is public and can be done by any nodes. When the miner solves the cryptographic post POW, the board cases the solutions uh, to the network. Other nodes can quickly verify the validity of the work, ensuring that the miner has indeed solved the puzzle correctly. So the third one, skin the game, is actually an economic cost. POW involves a significant investment in computational resource and electricity. This cost acts as a deterrent to any nodes considered act dishonestly. These expenses required to outpace the honest nodes in computational power is typically much greater than the potential reward. So, aligning economic incentive with honest participation in the generals, uh, this will be akin to ensuring that any general who tried to deceive the other would incur a great cost, perhaps even greater than the cost losing the battle. And that is my presentation.